In accordance with NFPA 40 and NFPA 70, also known as the National Electrical Code, the temperature rating is indeed applicable to switches and receptacles installed in Class 1, Group D, Division 2 locations. The primary function of this temperature rating is to prevent electrical equipment from becoming a potential ignition source in environments where flammable vapors may be present. Locating Class 6 rated switches and receptacles can be difficult because numerous manufacturers do not explicitly list these devices with a temperature class. Here are several strategies to find the equipment you need. Firstly, contact specialized electrical suppliers who may have access to equipment from manufacturers that offer temperature-rated devices. Secondly, contact manufacturers directly because they may be able to provide information on their equipment's temperature ratings, even if it's not explicitly stated in their catalogs. Thirdly, consider using alternative equipment that is listed for use in Class 1, Group D, Division 2 locations. While this equipment may not have an explicit temperature rating, it should meet the necessary safety requirements for such environments. Isolated ground receptacles play a crucial role in film laboratories by providing a low-resistance current path to earth without directly connecting the equipment to the grounding system. This design helps mitigate the risk of electrical shocks and minimizes noise interference on sensitive equipment. Although finding isolated ground receptacles can be challenging, they are available through specialized electrical suppliers. As an alternative, consider using grounding outlets equipped with ground fault circuit interrupters or GFCIs, which can provide a comparable level of protection. To further guide your understanding and ensure compliance with safety standards, consult the following resources. NFPA 40, which covers the storage and handling of cellulose nitrate film, provides comprehensive guidelines for ensuring safety in environments where this material is present. NFPA 70, the National Electrical Code, is the primary standard for electrical installations, providing detailed requirements for safe electrical practices. Appleton Lighting Fixtures offers a range of lighting solutions designed for hazardous locations, and our website provides detailed product information and specifications. Remember to prioritize safety and compliance with relevant codes and standards when selecting and installing electrical equipment in hazardous locations. The National Electrical Code, NEC, provides detailed guidelines for electrical installations in hazardous locations. Understanding these requirements is crucial for ensuring safety and preventing potential hazards. Class 1 locations are those where flammable gases or vapors are, or may be, present in the air in quantities sufficient to produce explosive or ignitable mixtures. Group D includes atmospheres containing acetone, alcohol, ammonia, benzene, butane, gasoline, hexane, lacquer solvent vapors, naphtha, or propane. Division 2 locations are those where ignitable concentrations of flammable gases, vapors, or liquids are present but are normally confined within closed containers or closed systems from which they can escape only in case of accidental rupture or breakdown of such containers or systems, or in case of abnormal operation of equipment. The 6 temperature rating indicates the maximum surface temperature that the electrical equipment will not exceed under normal operating conditions. For a 6 rating, this temperature is 85 degrees Celsius or 185 degrees Fahrenheit. This is crucial to prevent the equipment surface from becoming an ignition source for the surrounding flammable atmosphere. When selecting electrical equipment for Class 1, Group D, Division 2 locations, several factors must be considered to ensure compliance with safety standards. The equipment must be suitable for the specific hazardous environment. This means it should be designed and tested to prevent ignition of flammable gases or vapors. Ensure that all electrical equipment is properly grounded to minimize the risk of electrical shock and prevent the accumulation of static electricity, which could be a source of ignition. Wiring methods must comply with the NEC requirements for Class 1, Division 2 locations. This typically involves using rigid metal conduit or other approved methods to protect wiring from physical damage and prevent the escape of flammable vapors. Seals are required in conduit systems to prevent the passage of gases, vapors, or dust from one portion of the electrical system to another. These seals are typically installed at the boundaries of hazardous locations and where conduit enters enclosures. Overcurrent protection devices, such as circuit breakers and fuses, must be properly sized and installed to protect electrical circuits from overloads and short circuits. These devices should be located outside the hazardous area whenever possible or be enclosed in explosion-proof enclosures. Regularly inspect and maintain electrical equipment to ensure it is in good working condition and free from defects. This includes checking for loose connections, damaged wiring, and proper grounding. If modifications or repairs are needed, ensure that they are performed by qualified personnel using approved methods and materials. In Class 1, Division 2 locations, the NEC permits the use of several wiring methods. Rigid metal conduit, or RMC, is a common choice due to its durability and ability to provide a robust barrier against flammable vapors. Intermediate metal conduit, or IMC, is another option that offers similar protection to RMC but is lighter in weight. Electrical metallic tubing, or IMT, is permitted in some Class 1, Division 2 locations if installed with threaded fittings and other precautions to prevent the escape of flammable vapors. Type TC cable, or tray cable, is also allowed under certain conditions, provided it is approved for use in hazardous locations and is installed in accordance with the NEC. Sealing fittings are essential components in conduit systems used in hazardous locations. Their primary purpose is to prevent the passage of flammable gases, vapors, or dust from one area to another through the conduit. Sealing fittings must be installed at specific locations to be effective. Install them at the point where conduit enters or leaves an enclosure that is required to be explosion-proof. Install them within 18 inches of an enclosure containing arcing, sparking, or high-temperature devices. Install them at the boundaries of Class 1, Division 2 locations to prevent the migration of flammable substances. The selection and installation of lighting fixtures in Class 1, Group D, Division 2 locations require careful consideration to ensure safety and compliance. Explosion-proof lighting fixtures are designed to contain any internal explosions without allowing the escape of flames or hot gases that could ignite the surrounding atmosphere. These fixtures are typically made of heavy-duty materials such as cast aluminum or cast iron and have threaded joints and gaskets to ensure a tight seal. Vapor-tight lighting fixtures are designed to prevent the entry of moisture and corrosive substances, making them suitable for damp or wet locations. While they are not necessarily explosion-proof, they can be used in some Class 1, Division 2 locations if they meet the NEC requirements for non-sparking equipment. LED lighting fixtures are becoming increasingly popular in hazardous locations due to their energy efficiency, long lifespan, and low maintenance requirements. LED fixtures are available in both explosion-proof and vapor-tight designs and can provide significant cost savings over traditional lighting technologies. Emergency lighting is essential in hazardous locations to ensure safe egress in the event of a power failure or other emergency. Emergency lighting fixtures should be designed for use in hazardous locations and should provide adequate illumination to guide personnel to safety. Regular inspections and maintenance are crucial for ensuring the continued safety and reliability of electrical equipment in Class 1, Group D, Division 2 locations. Visual inspections should be conducted regularly to check for signs of damage, corrosion, or loose connections. Electrical testing should be performed periodically to verify the integrity of wiring, grounding, and overcurrent protection devices. Maintenance and repair should be performed by qualified personnel using approved methods and materials. Record keeping is essential for documenting inspections, testing, and maintenance activities. Accurate records can help identify potential problems early on and ensure that equipment is properly maintained. When addressing the specific requirements for film laboratories, additional considerations come into play due to the specialized nature of the equipment and processes involved. Nitrate film is highly flammable and requires special handling and storage to prevent fires and explosions. Film processing equipment often uses chemicals that can create hazardous atmospheres. The NEC has specific requirements for electrical installations in film laboratories to address these unique hazards. Isolated ground receptacles are particularly important in film laboratories to minimize electrical noise and prevent interference with sensitive electronic equipment. These receptacles provide a separate grounding path that is isolated from the normal equipment grounding system. Ground fault circuit interrupters, or GFCIs, are often required in film laboratories to protect personnel from electrical shock. GFCIs detect small imbalances in current flow and quickly trip the circuit to prevent injury. Emergency shutdown systems are essential in film laboratories to quickly de-energize equipment and shut down processes in the event of a fire, explosion, or other emergency. These systems should be designed to be easily accessible and operated by trained personnel. Ventilation systems are crucial for removing flammable vapors and maintaining a safe working environment in film laboratories. These systems should be designed to provide adequate airflow and should be equipped with appropriate filters and monitoring devices. Fire suppression systems are essential for quickly extinguishing fires involving nitrate film or other flammable materials. These systems may include automatic sprinklers, fire extinguishers, and other specialized fire suppression equipment. Training and education are essential for ensuring that personnel working in film laboratories are aware of the hazards and know how to safely operate equipment and handle materials. Training programs should cover topics such as fire prevention, electrical safety, chemical safety, and emergency procedures. Proper labeling and signage are essential for clearly identifying hazardous materials and equipment in film laboratories. Labels should be placed on containers, equipment, and storage areas to warn personnel of potential hazards. Regular audits and inspections are essential for ensuring that film laboratories are in compliance with safety regulations and best practices. Audits should be conducted by qualified personnel and should cover all aspects of the facility, including electrical systems, ventilation systems, fire suppression systems, and emergency procedures. It's vital to stay updated with the latest revisions and amendments to NFPA 40 and NFPA 70, as these codes are periodically updated to reflect new technologies, best practices, and lessons learned from past incidents. Regularly review these standards to ensure that your electrical installations and safety procedures are in compliance with the latest requirements. In summary, ensuring electrical safety in Class 1, Group D, Division 2 locations, particularly in film laboratories, requires a comprehensive approach that includes proper equipment selection, installation, maintenance, and training. By understanding the specific hazards and implementing appropriate safety measures, you can create a safe and productive working environment. Remember to consult with qualified electrical professionals and safety experts to ensure that your facility meets all applicable codes and regulations. The information provided here is intended for general guidance only and should not be considered a substitute for professional advice. Always consult with qualified experts and refer to the latest editions of NFPA 40 and NFPA 70 for specific requirements and recommendations. Selecting the correct type of wiring is crucial for safety in hazardous locations. Firstly, rigid metal conduit, or RMC, provides excellent physical protection and is suitable for severe environments. Secondly, intermediate metal conduit, or INC, is lighter than RMC but still offers good protection. Thirdly, electrical metallic tubing, or IMT, can be used if installed with threaded fittings and other precautions. And fourthly, Type TC cable, or tray cable, is allowed under certain conditions if approved for hazardous locations. Ensuring proper grounding is essential for preventing electrical hazards. A proper grounding system minimizes the risk of electrical shock and prevents the accumulation of static electricity, which could be a source of ignition. Grounding conductors should be sized according to the NEC requirements and should be securely connected to grounding electrodes. Regularly inspect grounding connections to ensure they are tight and free from corrosion. Overcurrent protection is a critical safety measure to protect electrical circuits from overloads and short circuits. Circuit breakers and fuses should be properly sized according to the ampacity of the conductors they protect. Overcurrent protection devices should be located outside the hazardous area whenever possible or be enclosed in explosion-proof enclosures. Regularly test overcurrent protection devices to ensure they are functioning properly. Implementing a comprehensive electrical safety program is essential for maintaining a safe working environment in hazardous locations. The safety program should include regular training for personnel on electrical safety procedures and hazard awareness. Conduct regular inspections of electrical equipment and systems to identify potential hazards. Implement lockout-tagout procedures to prevent accidental energization of equipment during maintenance and repairs. Establish an emergency response plan to address electrical incidents and ensure the safety of personnel. Regular training and education are essential for ensuring that personnel working in hazardous locations are aware of the risks and know how to work safely. Training programs should cover topics such as electrical safety, fire prevention, hazard communication, and emergency procedures. Training should be provided to all employees who work in or around hazardous locations, including electricians, maintenance personnel, and operators. Refresher training should be provided periodically to ensure that employees retain their knowledge and skills. Proper ventilation is crucial for maintaining a safe atmosphere in hazardous locations. Ventilation systems should be designed to remove flammable vapors and gases and prevent the accumulation of explosive concentrations. Ventilation systems should be regularly inspected and maintained to ensure they are functioning properly. Airflow should be monitored to ensure that it meets the required levels. Static electricity can be a significant ignition source in hazardous locations. Static electricity can accumulate on non-conductive materials, such as clothing, equipment, and plastic components. To minimize the risk of static electricity buildup, use conductive materials whenever possible. Ground non-conductive equipment and materials to dissipate static charges. Control humidity levels to reduce the buildup of static electricity. Provide personnel with static dissipative clothing and footwear. Hot work permits are required for any work that involves open flames, welding, cutting, or grinding in hazardous locations. The permit process ensures that all necessary precautions are taken to prevent fires and explosions. Before issuing a hot work permit, assess the area for flammable materials and ensure they are removed or protected. Provide fire extinguishers and other fire suppression equipment. Monitor the area during and after hot work to ensure that no fires or explosions occur. In addition to the specific requirements for Class 1, Group D, Division 2 locations, there are also general electrical safety requirements that apply to all electrical installations. These requirements include proper wiring methods, grounding, overcurrent protection, and equipment labeling. All electrical work should be performed by qualified electricians in accordance with the NEC and other applicable codes and standards. Regular inspections should be conducted to ensure that electrical systems are in good working condition and free from hazards. Remember that electrical safety is everyone's responsibility. By following these guidelines and working safely, you can help prevent electrical accidents and ensure a safe working environment for yourself and others.